Hello, friends. Welcome to another session on number system, and this is going to be the last session of number system in terms of concepts. We will follow up with three sessions on number system, which will be focusing on all the problems on number system. So we have done, I think, 6 to 7 sessions on number system till now, focusing on the basic concepts and some examples of those concepts. So today we will be doing the last session on concepts, and today we are going to talk about one of the most important topic in number system and one of the little conceptual topic in number system, which is the remainder theorem. So remainder theorem is basically nothing but it talks about how you can calculate the remainder of a given number when divided by a certain another given number. So let's say we all know if I divide 10 by 3, I will get a remainder. I will get a, if I just write, that means I'm calculating the remainder. So the remainder of this is 7. Now, if I say you do 7 to the power 237 divided by 29, can you tell me the remainder? It's not an easy task. So you need to know some of the concepts, some of the theorems, some of the formulas to solve problems like this. And we'll come back to this problem later, but let's see how we can, what are the different concepts or theorems you need to know when it comes to remainder theorem. So let's get started right away. So the first one, or we'll say the first, or we'll say the concept one talks about, I'll first write the theorem and then I'll take an example and explain it. So say if fx is divided by x minus a, then it leaves a remainder of f of a. If and only if fx is polynomial. Now, what do I mean by fx is polynomial? Let's understand that first. So fx is polynomial means fx will be in a form of a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on. So fx cannot be a trigonometric, logarithmic, or a exponential expression. So fx cannot be a trigonometric function, logarithmic function, exponential function. Fx has to be a polynomial. So fx is a polynomial only when fx is in a format like this. Now, if fx is in a format like this, let's see how we satisfy the concept that we talk about. If fx is divided by x minus a, then it leaves a remainder of fa. So let's say my fx is x cube plus x square plus 1 and divide by let's say x minus 1. Okay, so let's do a normal algebraic division that we have learned till now how to do algebraic division. So x minus 1, x cube plus x square plus 1. So first we'll multiply with x square, so that I'll get x cube here minus x square here. With a minus sign, it will become 2x square plus 1. Now, if I put up plus 2x, we multiply by 2x, so 2x into x will give me 2x square minus 2x square minus 2x. So what I'll get is, so what I will get from here is a 2x minus 1, 2x minus 1 here. So from here I will get a 2x minus 1. Now with 2x minus 1, if I can multiply this with 2, I'll get 2x here and I will get minus 2 here. So after subtracting what I'll get 1 as a remainder. Think on this and okay, let me write it again. Let me do it in a proper way so it's in one place and you don't get confused. So let's say I want to divide this. Okay, let's go to the next page. So if I do x minus 1, x cube plus x squared plus 1, I'll multiply with x square first. So what I'll get x cube minus x square. Okay, so this minus this get plus, so I'll get 2x squared plus 1. Now if I do another 2x multiplication, I'll get 2x square minus 2x. So with a minus sign and there is a plus sign, I'll get a 2x plus 1. Then I multiply with 2. So I'll get 2x minus 2. Again minus plus, so I'll get 3. So 3 is my remainder with the normal division. Now, what was my fx? My fx is x cube plus x square plus 1. Now, if I divide by x minus a, what is my x minus a here? My x minus a here is x minus 1. So my a is equal to 1. Now, what my theorem says, if fx divided by x minus a, it leaves a remainder of fa. So my remainder in this case will be f of a or f of 1, or we can say fx is this. So f of 1 will be 1 cube plus 1 square plus 1 will get 3 as a remainder. So which is both the things are same. So this is the first theorem that we have learned. So fx when divided by x minus a leaves a remainder of fa, but only if fx is a polynomial function. Okay. Now let's see some of the examples of this. Let's take an example. Let's say 2 to the power 72 is divided by 7. What is the remainder? So 2 to the power 72, it on the face value, it does not look like kind of a fx kind of a scenario. You cannot do fx kind of a formula here, it looks like, but let's see if we can convert this. So what is 2 to the power 72? Can I say it is 2 cube whole to the power 4? Okay, so 2 cube whole to the power 4, right? So if and 7, I can write it as 2 cube minus 1. So if I say my x is equal to 2 cube, then my f of x equal to 2 to the power 72. Sorry, my f of x is nothing but 2 cube whole to the power 24, or basically x to the power 24. My f of x is nothing but, so if I consider this as my x, then my f of x is nothing but x to the power 24. If my f of x is x to the power 24, and x is 2 cube, so f of x is divided by x minus a. So what is fx? Fx is x to the power 24 divided by x cube, x minus a. Okay. Now what is my a? So my a here, I can say this is my x minus a. So in this case, my a is equal to 1 because this is my x. So does it follow the same criteria? X to the power 24. X to the power 24 is a polynomial for you. Now x to the power 24 divided by x minus a gives me a remainder of f of a. Now a is 1, so that means f of 1. So if x is x to the power 24, so f of 1 will be 1 to the power 24 or as a remainder of 1. So you get a remainder of 1. So it's not that the number is given, you can't put it into a form of polynomial, you can put a form of polynomial. So what we have done, we have seen 7. Now 7 in a x minus a format can be written as maybe 8 minus 1, because 2 cube 3 is a power of 7, 3 is a factor of 72 also. So, writing 7 as 2 cube minus 1 and 2 to the power 72 as 2 cube to the power 24, you are then fixing your x as 2 cube. So then x is basically, which is common in your denominator in part of x minus a, and your numerator as part of fx is basically the same, which is 2 cube. So then you identify the x first and then you write those in terms of a polynomial. Then it becomes very easy. Okay. So this is one example of doing it. I will give you one more problem which you can try at home and then let me know. The one problem I will give you here only. You can try this at home. 3 to the power 28 divided by 51, find the remainder. It will follow the same approach that we did, but I want you to, sorry, this is just let me do a change. 3 to the power 28 you won't be able to do. Let's do 3 to the power 51 divided by 28. Now, let's do the remainder. You can try this at home, and if you can drop me the answer in the comment section, or if you are stuck, you can call it out in the comment section. We'll be able to explain in the comment section only. But do try this at home. It's the same approach like we did 2 to the power 72 divided by 7. In the same way, can you do this 3 to the power 51 divided by 28 at home? So this is the first concept when it comes to remainder theorem. The second concept, or you'll say concept 2, basically focusing on two things. One is, say, if a plus b plus c gets divided by r, then the remainder is same as remainder of a by r plus remainder of b by r plus remainder of c by r. Okay, for easy understanding, let's keep this as n. For easy understanding, let's keep this as n. A, B, C by n. So then this is this. Once A by n plus B by n plus C by n. Okay. One example. So for example, if I want to say remainder of, let's say 30 divided by 7, for example, I'm taking. So I can write this as remainder of 14 plus 7 plus 9 by 7. Okay. So 14 by 7, the remainder is 0. Then 7 by 7, the remainder is 0. 9 by 7, the remainder is 2. You do the same. Remainder of 30 by 7 is also 2. So this is one easy one. May not be used too many times. Problems like this may not come much, but just to know this A. The B is a very important one. B is a very important one. It says if A into B into C divide by N, remainder is same as remainder of I'll just write R, same as remainder of a by n into remainder of b by n into remainder of c by n. Okay. And we'll see some of the problems based on this. Let's say 25, 27, 29 gets divided by 13. Now, if this is given to you, so how will you write? It's the remainder of 25 by 13, sorry, into remainder of 27 by 13 into remainder of 29 by 13. So these are the three remainders. Okay. Now, if I know this, the first remainder will be 12, right? Into the second remainder will be 1, and the third remainder will be 3. Now 12 into 1 into 3 is 36. 36. Now 36 cannot be the remainder when something is divided by 13. The remainder has to be less than 13. So then 36, it's the same way, it will be the remainder of this by 13. So that means it will be a remainder. You further do the remainder calculation, and then 13 to the 26. So the remainder is 10. So the remainder is 10. So you do this till you get a remainder which is less than 13. Okay. So this is one type of problem. So when you individually found the remainder, and if the multiplication result is more than the divisor, then you do the same way, calculating the multiplication value, multiplied value with the same number, and get the remainder. That will be the final remainder, will be the actual remainder of the starting one. Let's take another example and let's see if we can understand this further. Let's say 7 to the power 69 is divided by 4. Okay. So 7 to the power 69 is divided by 4. So can I write 7 to the power 69 is the remainder is same as, this remainder is same as, if I do remainder, what is the remainder of, let's say 7 into 7 to the power 68 by 4. So in this case, my remainder, or you do 7 to the power 69 is same if you do divide 7 by 3. So it will basically same as writing remainder of 3 to the power 69 by 4. It is the same way of writing 3 to the power 69 by 4, because if you do, you don't need this step actually. So 7 to the power 69, if you divide by 4, 7 gives a remainder of 3. So it's basically nothing but the same way of writing 3 to the power 6, same remainder should give you 3 to the power 69 by 4. Okay. Now, if I do write this as 3 to the power 69, which is 3 square, and why I'm writing 3 square? Because I'm trying to get a remainder of 1 by a power of 3 when divided by 4. So power of 3 gives me a remainder of 1 when it is divided by 4. So 3 square, 3 square is typically gives me a remainder of 1. So 3 square into, let's say 34, that is 68, and 3 would divide by 4. So let's see what I get. So from here, if I do here 3 square, so remainder of 3 square to the power 34 divided by 4 into remainder of 3 by 4. Now remainder of 3 by 4 gives me a remainder of 3. So here is a remainder of 3, and here I get a remainder of 3 square means I get a remainder of 1. 3 square is 9. 9 divided by 4, remainder of 1. So it's nothing but remainder of 1 to the power 31 by 4. So final remainder is 1 into 3. Answer is 3. So you get it. How we get it? 7 to the power 69. 7 to the power 69, I know 7 divided by 4 gives me a remainder of 3. So if I ignore this step, then I can directly write here from here. So that it's basically nothing but 3 to the power 69 by 4. Now 3 to the power 69, you need to look for a power of 3 which gives a remainder of 1 or minus 1. So minus 1, when the remainder is minus 1, that means the actual remainder is 4 minus 1, 3. If the remainder of something divided by 4 remainder is 2, that means the number is 6. If the remainder is minus 2, that means the remainder is 2. So 4 minus 2 is 2. So you have to look for a remainder which is either 1 or minus 1. So I'm looking for a remainder which is 1. So then I break 69. 3 square I know is 9, which gives me a remainder of 1 when divided by 4. So I put 3 square whole to the power 34. So this entire piece, 3 square whole to the power 34, is becoming, this is 34, I'm sorry, this is 34. So this whole piece becoming 1 to the power 34 by 4. 1 to the power 34 is 1. When divided by 4 gives me a remainder of 1. When the 3 that is left, when divided by 4 gives me a remainder of 3. So that becomes 1 into 3, 3. So that's how you can calculate the remainder. So these are very important type of problem. I again give you a couple of problems on the same note to solve at home, and then we'll deep dive in the problem session. You can note down a couple of problems, and I'll write it here. 9 into 5 to the power 40 divided by 8. This is one. And the second one, 5 to the power 6 divided by 7. So both of them will be very similar. The way we solve this, that multiplying three numbers or more, multiplication of a set of number gives the same, when divided by a particular number gives the same remainder. When you individual numbers, you divide by the same value and get the individual remainders. And that way you can calculate this. So this is a very important way of understanding how the remainder works, and the very usable, or a lot of application, lot of problem will depend on this concept. So we learned two concepts. First is fx divided by x minus a gives a remainder of fa. Second concept we learned, when there is a sum and when there is a division or there is a multiplication, how the remainder theory works. Okay, so these are the two important one. Now let's move to concept 3, and concept 3 is also very critical. Concept 3. Concept 3 basically talks about if a number, if m is divided by n, if m is divided by m, the remainder is same as m divided by a into b, where n is equal to a into b and a, b, AB are co-prime. What do I mean by AB co-prime? AB co-prime means HCF of AB is equal to 1. Okay. So then you do M by A and M by B, and you will get the remainders. So we'll take an example and again solve it so that you can understand this well. Okay. So let's say a remainder of m by n, and how we can solve this actually. Let's see. Remainder of m by n is same as remainder of m by a into b. Remainder of m by a is r1, and remainder of m by b is equal to r2. Then remainder of m by n is equal to ax r2 plus by r1, where ax plus by has to be equal to 1. So this is a very important theorem. M by n when m is divided by n, where n can be broken into smaller factors like a into b, where a and b are co-prime. Then remainder of m by n is can be written as AX R2 plus BY R1. Now, what is R2? What is R1? R2 is when M is divided by B. That's the remainder. R1 is when M is divided by A. And also the condition that needs to satisfy is AX plus BY equal to 1. Let's take an example. So let's say 7 to the power 15 is divided by 15. What is the remainder? So let's say 7 to the power 15 is 15 I can write it as 3 into 5. So my A is 3 and B is 5. Now if I do a 7 to the power 15 by 3, what will be my remainder? My remainder is same as 1 to the power 15 by 3 or 1. So this is my R1. How I get 1? Because 7 by 3 gives me a remainder of 1. 7 to the power 15 by 3 is same as saying as 1 to the power 15 by 3. Now 1 to the power 15 is 1. So remainder is 1. Now what will happen if remainder is 7 to the power 15 by 5? 7 to the power 15 by 5 is same as writing as 2 to the power 15 by 5. Now I know 2 to the power, now you look for a power of 2 that gives the remainder of plus or minus 1. Let's see plus 1. So 2 to the power 4, I know 16. 2 square is a minus 1. Let's take it aside for now. 2 cube is plus 3, gives a remainder of 3. 2 to the power 4 when divided by 5 gives me a remainder of plus 1 because 16 divided by 5, 5 3 is a 15, gives a remainder of plus 1. So can I write this as 2 to the power 4 whole cube into 2 cube? So this entire piece, so the first piece will give me a remainder of 1 to the 1 by 5, 1 cube by 5. Because 2 to the power 4 when divided by 5 gives a remainder of 1. So the first piece will give me a remainder of 1 cube by 5, which is 1. And the second gives me a remainder of 8 by 5. That means it's 1 into 3. So the remainder is 3. This is R2. So I know A, B, I know R1, R2. So can I say the remainder of 7 to the power 15 by 15 is same as, let's say, what we said, AX R2, BY R1. Be very careful, it's not AX R1, BY R2, it's AX R2 plus BY R1. So here in this case, we can say, what is A? A is 3, X, what is R2 into 3, plus B, what is B? 5, Y, and what is R1? It's 1. So the remainder will be 9x plus 5y. What condition it needs to satisfy? It needs to satisfy the condition ax plus by equal to 1. So what is ax? Ax is 3x plus by, which is 5y. This is equal to 1. So in this case, I can say if this condition has to be satisfied. So I need to find out for which x and y this will satisfy. So if x is -3 and y is 2, and you can put any random number, some trial and error is needed in this case. So if x I put -3 and y is +2, I'll get 3x plus 5y equal to 1. So I know the value of x and y. Now if I put it in this, my final remainder becomes 9 into -3 plus 5 into 2, right? So 9 into -3 is -27. -27 plus 5 into 2 is 10. So this is -17. So -17 is the remainder. Now how to treat with a minus remainder? So when you do with 15, you can't have a -17 as a remainder. So -17 as a remainder is same as -2 as a remainder, because 15 by 7 is 2. So it's same as -2 as a remainder. Now 15 has a remainder of -2. That means the final remainder is 15 minus 2, 13. That's how you calculate the final remainder. So If this is -2, your remainder has to be 13. So you understood the process. We divide 15 into 3 into 5. Individually get the remainder of 7 to the power 15 for 3, 7 to the power 15 for 5, and then put the equation. And then from there, we did some trial and error and then got the final one. So this is the little complex one and a little conceptual one. So the concept 2 that we have talked about, the remainder when a into b into c divided by n, how you find the remainder, and this one where the only the denominator can be broken into smaller fractions, then this is the part that you need to be little cautious about. These two are very important theorem for your remainder theorem. Now again another concept 4. And if you have any doubt, please drop a note in the comment section and we'll be able to help you from there. So the concept 4 talks about if m is divided by n, then remainder of m by n is remainder of m by n will be what? Okay, let me write it this way. Is same as remainder of, if I can write it as m as k into a and n as k into b, to b, which is equal to k into remainder of a by b. K into. So basically, if there is a common factor between m and n, so if I can write m as k into a and n as k into b, then the remainder of m by n is, which is the remainder of this, can be written as k into remainder of a by b. So you focus only on the part which is not common and multiply whichever is taken out. Okay. So this is another concept which is a basic one. If there are any common factor between numerator and denominator, you take that common factor out, and whenever you get whatever is left, do the remainder calculation on that, and once you get the value, you multiply with that common factor k to get the final remainder. Okay, so this is another important concept that you need to learn. There are one more concept. So let's say concept 5 says if m and n are coprime numbers, and you understand what is a coprime number. A coprime number is when m and n has a HCF of 1. If m and n has a highest common factor as 1, that's when they said are coprime. If m and n are coprime numbers, then m to the power n divided by n, this remainder of m to the power n divided by n. So m to the power n divided by n gives the remainder of m. Similarly, if remainder of m to the power n minus 1 divided by n, m to the power n minus 1 divided by n, then you get a remainder of n. Okay. Or sorry, you get a remainder of 1. Okay. So these are the two concepts you need to understand. If m and n are coprime, then m to the power n by n gives a remainder of m. M to the power n minus 1 by n gives a remainder of 1. So for example, let's say 7 to the power 71 divided by 7 to the power 71 divided by 11. So if I have this 7 to the power 71 divided by 11, so what is the remainder? So you can write 7 to the power 71 is same as 7 to the power 10 into 7 to the power 10. Let's say 7 times 3, 4, 5, 6, just 1, 2, 3, 6, 7 into 7. Okay. Now, all this 7 to the power 10, I can write it as 7 to the power 11 minus 1. So does it make sense with this? So 7, all of this will be individually divided by 11. So 7 to the power 11 minus 1 by 11 and so on. And the last one will also be 7 by 11. So all this part, all this will give me a remainder of 1 because of satisfying this criteria. 7 to the power 11 minus 1 by 11, where 11 is basically nothing but your n and 7 is nothing but your m. So all this will give me, so if I write here, so it will be 1 into 1, 3, 4, 5, 6, 7, 1 into final one is 7. So your final remainder is 7. So that's how you do it. So sometimes there will be straightforward, you can do it, but remember this concept. So this is the fifth concept that we learned. M and n are co-prime. Then remainder of m to the power n by n is m, and m to the power n minus 1 by n is basically 1. Okay. So that's what we learned. Also, we can do. Let's go to the next set of concepts. Say concept 6. So concept 6 is basically a mix of concepts or mix of formulas, I'll say. So first is n factorial. N factorial is always divisible by n. So product of n factorial means 5 into 4 into 3 into 2 into 1 is always divisible by n. Or the other way you can write it as product of n consecutive integer is always divisible by n. So product of n consecutive integer. So that means I can say 10 into 11 into 12, 3 consecutive integer will be divisible by 3. Similarly, 3 factorial is also divisible by 3. 3 factorial is nothing but 3 into 2 into 1. So both of these are possible. Okay, so this is your first one. The second one basically talks about remainder of n minus 1 factorial when divided by n, you get a remainder of n minus 1. Okay, then C talks about if there is a remainder of n minus 2 factorial when divided by n, you get a remainder of 1. So let's say 30 factorial divided by 31. Your number remainder will be 30 minus 1. 31 minus 1, 30. The 29 factorial divided by 31. Your n is 31, your remainder is 1. So that way. These are good things to remember. One is if a digit written p minus 1 times, it is divisible by p if p is greater than 5 and prime. So if a digit is written p minus 1 times, it is divisible by p where if p is greater than 5 and a prime number. So let's say I have written 2, 2, 2, 2, 2, 2. So I have written 6 times 2. This is divisible by 7. this is divisible by 7 because 2 is written 6 times, which is uh, divisible by 7 because 2 is written p minus 1 times, where p is 7. So for example, this is also true. On the last part, before we wrap up the remainder theorem, is the last part of concept 7. So we know there is a huge set of concepts that you need to learn for remainder theorem, but this is a very important piece of your number system. So that's why we keep it at the end. So when you understand all the basics of number system, we'll do this remainder theorem. So this is the last concept for remainder theorem, and then we can wrap up. So it says, so a to the power n plus b to the power n, and if you have a to the power n minus b to the power n, and if you have a plus b and a minus b. So this is written as when a to the power n plus b to the power n, or a to the power n minus b to the power n is divided by a plus b or a minus b. What happens? Okay, now I'll form a table and I will. So this is a to the power n plus b to the power n divided by a plus b is divisible when n is odd. A to the power n plus b to the power n by a plus b is divisible. So this is basically divisibility. So I'm not talking about the remainder here. I'm talking about when a to the power n plus b to the power n is divisible by a plus b when n is odd. A to the power n minus b to the power n will be divisible by a plus b when n is even. A to the power n plus b to the power n divided by a minus b, there is no generalized rule, and it is always a factor. So a to the power n minus b to the power n will always be divided by a minus b. So this is the rule of divisibility. So you can think of a divisibility. So a to the power n plus b to the power n is divided completely by a plus b when n is odd. A to the power n minus b to the power n is completely divided by a plus b when n is even. A to the power n minus b to the power n always divide by a minus b respective of the value of n. And for plus a to the power n plus b to the power n cannot be generally told when it is divided by a minus b. So this is the last concept, a good to know kind of a concept. So what we have covered 6 to 7 concepts. So this is one. Then the previous concept we learned about n factorial when divided by n, n minus 1 factorial when divided by n, when product of n consecutive integer divisible by n. If a digit is written p minus 1 times, it is divisible by p. If p is more than 5 and prime. So these are very important nuances you need to know. So you can take these concepts, put in a piece of paper, see it before you do number system problem, or when you are going in a mock exam, you can see these formulas quickly, these concepts quickly, so that it's always on top of your mind. Then we talk about some of the co-prime member of M and N and how they interact. Then before that, we learned this when there is a common factor between M and N, how to apply that. The most important, I'm still saying, concept 3 is very, very critical. You see a lot of application on problems on concept 3, and this concept 2b is also very, very critical. So these are the two most important concepts of your remainder theorem, and you will be seeing most application of it. And then the first concept was there. So this is the high level 6 to 7 concepts we have learned in remainder theorem. I'll put all the videos of number system in the description box. You can go through them for a revision before we start the problem deep diving session from next class onwards. So we'll do 3 problem sessions completely covering all the number systems. So whole it will be around 9 to 10 complete videos on number system, which will help you enable it very well. and we left no stones unturned, but you have to do number system well in order to score well in that or any other MBA entrance exams. It's a topic you cannot avoid. It's not very comfortable. I know at times it may get little tricky, a little make you uncomfortable. That's why we are doing it piece by piece, bite by bite, and we'll take it slow, but we'll ensure we understand this and master this concept very well. Okay. Hope this session is helpful. Any doubt, please drop a note in the comment section or drop me an email. I will able to respond. Thank you. See you next time in the problem session on number system. Bye.